All right, 1.2, formulas and word problems. So when it says formulas, it just means can you solve a formula for a particular variable, which is honestly more of a science thing than a math thing, but they have it here and there will be one on your test. The one on your test, I believe, is going to be fairly similar to number two, maybe slightly more complicated than that, but not as bad as like four or five. All right, so if we're going to take this volume is equal to length times width times height and solve for width, these are all being multiplied, so we can just divide by the length and the height. And so V over LH is equal to W, and that's all there is to it. Number two, that's the equation of a line in standard form. We're trying to get y by itself. So it's like we're trying to get slope-intercept form. So we want this by by itself first. We're going to subtract the ax. So by will equal c minus ax. Now, if I was actually trying to solve like for slope-intercept form, I would probably rearrange my terms differently. But for this, all we're really trying to do is prove that we know how to get y by itself. So we can divide by b, and then we can leave our answer as y is equal to c minus ax over b. Or if you wanted, it could be c over b minus ax over b. Either one of those is acceptable. All right, number three, that's the formula to convert Celsius to Fahrenheit or Fahrenheit to Celsius, whichever. If we're trying to get F by itself, I can get rid of this without distributing. If I just multiply by 9/5, then we're going to have 9/5 C is equal to F minus 32. And then we can add 32 and have 9/5 C plus 32 is equal to F. All right, number four, we're trying to get R by itself. So we need to get it out of the denominator. So we're going to use the skill we learned with the rational functions. Sorry, I was trying to send a text message. I apologize. Not a very good multitasker. We're going to use what we learned with the rational equations, trying to get the denominators off the bottom. So we multiply by a common denominator of R, P, Q. So multiply that to all of them. So the P's will cancel and you'll have RQ. The Q's will cancel, you'll have RP. The R's will cancel, you'll have PQ. All right, so then you want R by itself. So we're going to subtract RP. Let me make sure I'm in the habit of showing all of my work because you have to on a tech test. So we're going to subtract RP because we need R's on the same side if we're going to try to get them together. All right, so then the trick here is if I need a single R, if it's in two terms, I can factor it out as a GCF. And then R is being multiplied by that parenthesis. So to get rid of the extra, this parenthesis, I can just divide by it. So we get that R is equal to PQ over Q minus P. All right, so number five, the one on your Math Excel that's like these last two, I think it has like an L and an L1 and an L2. I don't know why they do multiple the same variable with subscripts instead of using different variables, but if you have trouble with it, let me know and I'll help you work it. All right, so for this one, it's a lot like what we did on number four. We're trying to get x, so we need the x's all on the same side. So it would look like this. And then factor out that x. And then you can divide by that parenthesis, the z squared plus w squared minus y squared, on both sides. So we end up with x is equal to 5 over z squared plus w squared minus y squared. All right, so that is the formula part. So then we have the word problems. All right, so on these word problems, you're going to have a couple on your test, but they're not going to be the harder ones. So out of these two, the one on your test is going to look a lot like number one. Okay, on most of the problems, you're going to have one on your test that looks a lot like number one. Number two is just because they try to up the ante on you on Math Excel. So giving you an example of what's in Math Excel also. All right, so a frame maker made a large frame using 10 feet of molding. If the length of the finished frame was 2 feet more than the width, then what were the dimensions of the frame? All right, so I'm looking at the test to make sure that I'm not giving you false information. And it will be more like this one, but I need you to understand that you have to make some statements at the beginning about where your variables are coming from, where your information is coming from. So one of the points on your test for a problem like this is that you have to take this and write it as like a little equation. That was a horrible line that I just drew there. So this part here, length of the frame was 2 feet more than the width. So you have to start by saying, let length equal, or you can write that like as an equal sign, equal 2 feet more than the width. So the width plus 2. So if you're thinking about a rectangle, you've got the short sides or the widths. They don't have to be the short sides, but we'll say that they are because the length is longer. And then these lengths are the width plus 2. All right, so then other information is we've got 10 feet of molding. Well, remember, molding goes around the outside of something. So we're saying perimeter. So if we add up all the sides, so if we take this plus this plus this plus this, that should add up to 10. So then we have 4w plus 4 is equal to 10. Then we subtract the 4 and then divide by this 4. And we get a width of, what is that? 3 halves, 1.5 feet. And then we know the length is 2 more than that, so 3.5. All right, so you have to write this for a point. You have to write an equation and solve it. And then you have to write your answer specifically to make sure that they know that you know what you found. Okay, so to get all of your points, you got to have all of that. All right, number 2. Paul owns a 4-sided lot that lies between 2 parallel streets. If his 90,000 square foot lot has 500 feet frontage on one street and 300 on the other, how far apart are the streets? All right, so I have a street and a street. On one of them, I have 300 feet. And on the other, I have 500 feet of my property that butt up to the road. Okay, so that means that if I draw this, I'm making a trapezoid. All right, so they want us to figure out the height of this trapezoid because they want to know how far apart the streets are. So they really want to know this distance right here. Okay, so that's the height of the trapezoid. We know that 90,000 square feet is area. So remember the area of a trapezoid, the formula is this. So we know 90,000 is going to equal half of the height times 300 plus 500. All right, so for this one, you would just have to say let h be the height of the trapezoid, or h be the distance between the two streets. Okay, so you would have to say let h equal the distance between the two streets. And then you can write your formulas. Anytime you use a formula, you got to write it down. So this is a formula, so write it down, fill in the information, and then to solve is 1/2 h times 800. So then it would be 400 h. Then we can divide by 400. And you get, I don't remember. So let's check it. 90,000 divided by 400 is 225. All right, so again, make sure you have units on your answer, and make sure that I get all of my points. You're going to start with a statement that says h equals how far apart the streets are, and you're going to end with the streets are 225 feet apart. All right, so moving on to the next type, mixture problems. All right, so for mixture problems, again, you're going to have to do a statement about what your variable stands for, and then solve the problem, and then at the end, give a statement about what your answer is. Okay, so again, the one on the test is going to be a lot like number one, not to number two. So when I'm studying number one. Number two is just to help me with the weird ones on Math Excel. All right, how many gallons of milk containing 5% butterfat must be mixed with 90 gallons of 1% milk to obtain 2% milk? All right, so let's think about this. We're taking something and mixing it with something and getting something. All right, so how many gallons of 5% milk must be mixed with 90 gallons of 1% milk to get some 2% milk? So here's the thing that makes people wonder, like, where did she come up with this? So up here, I need gallons. Well, if I take X gallons in this bucket and 90 gallons in this bucket, and I pour them both into this bucket, then this bucket has whatever X plus 90 is. All right, so then remember that percents have to turn into decimals if you're going to use them to do math. And remember that you're moving it twice. So this should definitely be 0.01, not 0.10. Sorry. Slightly dyslexic moment there. All right. So your statement about your variable is you would say let x equal gallons of 5% milk, or 5% butter fat, not milk, 5% butter fat. All right, so 0.05, which I believe is whole milk, by the way. Just for those of you that like to know where these things come from. All right, so we distributed the 0.02 and multiplied this together. Now we're going to get our variables on the same side. Sorry, I pushed a button. Now I have no idea what I'm doing. All right, here we go. So we're going to move 0.02x, and then we're going to move the 0.9. And we will get 0.03x is equal to 0.9. And then divide by 0.03. And we get, is it 30? Yes. All right, so then you would need a statement that says you have 30 gallons of 5% butterfat will be mixed with the 90 gallons of 1% to get 2%. You don't quite have to be exactly that specific. You don't need like a complete sentence that has all of that, but you need to make sure that this is at least labeled gallons of 5%. All right, so number 2 is a little harder to wrap your head around because of the whole idea of what's happening with emptying and refilling. So, a mechanic is working on a car with a 20-quart radiator containing a 60% antifreeze solution. How much of the solution should he drain, then replace with pure water to get a solution that is 50% antifreeze? All right, so again, you're taking this and adding something and getting something. The something that we want is our 20-quart radiator with 50% antifreeze. That's his goal. He wants a solution that's 50%. His radiator is 20 quarts. All right, so he starts out with 20 and he pours some out. So what's left is 20 minus whatever he pours out. And that is 60% antifreeze. Okay, so whatever was there after he poured some out, that's 60%. And that's whatever the 20 quarts were minus however much he poured out. And then over here, we're adding back water, so 0%. So that one's really just going to be nothing. So we take 60 times 20 minus x. You're adding 0 times x, and you're getting 50% times 20. All right, so 60% of 20 is 12. And I'm going to just call it 0.6x. We're going to ignore this because it's a 0. And then 50% of 20 is 10. So then we can subtract the 12. It's 10. I don't know why I put a decimal point there. Just 10. So then we got negative 0.6x is equal to negative 2. So divide by that negative 0.6. And we get that to be 3.3 repeating, or 3 1/3 quarts. All right, so again, start with x is the amount of water that is added, or the amount of antifreeze that is drained. Since they say how much of it should be drained, I would say call x how much is drained. And then at the end, say that we drained 3 1/3 quarts. All right, number 3 is a mixture problem without percents. You should like it better. So again, we're taking a bucket and combining into a new bucket. All right, this time we're talking about raisins and bran flakes. So we're going to assume we're making some raisin bran. We know that raisins are $4.50 a pound. We know that bran flakes are $2.80. How many pounds of raisins should be mixed with 12 pounds of bran flakes if we want a mixture that's $3.14 a pound? So this would be x plus 12. If I take these two and dump them into here, that's how much is there. So we're letting x equal the number of pounds of raisins. And when we solve for x, we will know how many pounds of raisins. All right, so 450x plus 280 times 12 is 3360. 314 times 12 is 3768. All right, so then I'm going to do this in a different color this time so that we can see. We're subtracting this over here. And then we'll subtract this over here. We're trying to get variables on one side and constants on the other. All right, so 450 minus 314 is $1.36. And 37.68 minus 33.60 is $4.08. And if we divide by $1.36, then we get 3. So 3 pounds of raisins. All right, next type. All right, so again, the one on your test will look a lot like number 1. All right, Leah can trim the hedges around her property in 8 hours by using an electric hedge trimmer. Ryan can do it within 15 hours using a manual trimmer. How long would it take them to trim the hedges together? So what you have to think about these is if Leah is doing the entire job in 8 hours, what is her rate? Well, if she can do all of it in 8 hours, then she should be able to do an eighth of the job in an hour. So an eighth of the job per hour for Leah. Ryan can do it in 15 hours, so he's going to do a 15th of the job an hour. And together, they're going to end up doing one whole job. All right, so then to solve this, we're going to multiply by a common denominator. So 8 times 15 is 120. Is there something smaller than that? Likely, but it's not important. 120 works. So this would be 15h plus 8h is equal to 120. So then 23h is equal to 120. So then divide by 23 and we get sorry. You get 5 point blah 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 blah. Let's see, 5 points. 21739. And it keeps going. All right, so the way they want answers for these on your test and in Math Excel is they're going to want hours and minutes. All right, so that means we have 5 hours. And then to get the minutes, you're going to just multiply the decimal part by 60. So when you divide 120 by 23 and you get 5 point whatever in your calculator, then you're going to subtract the whole number part. So subtract the 5. So just the decimal is left and then multiply by 60 and that'll give you some minutes. So in this case, it's 5 hours, 13 minutes. I don't know why I can't draw straight lines today. All right, so number 2, Charlie can empty the cookie jar in an hour and a half. It takes his mother 2 hours to bake cookies to fill the jar. If the jar's full when he comes home and his mother continues baking and restocking, how long will it take him to empty the cookie jar? So we're going to take this from Charles' perspective. So first of all, coming over here, 1.5 is the same thing as 3/2. So if I try to do his rate 1/3/2, that ends up being 2/3. So if he can eat 1.5 jars, or he can eat the jar in 1.5 hours, then he's eating like 2/3 of the jar an hour. All right, so that's what he's trying to do. His goal is to eat one whole cookie jar. His mom is working against him, so we're going to subtract. And if she can fill it in 2 hours, then she's doing half of the jar in an hour. All right, so then our common denominator here would be 6. So then 2/3 of 6, we get 4. Half of 6 is 3. So we get 1. Oh, this is a 6 because 1 times 6 is 6. I was trying to figure out like that. I knew 1 wasn't the right answer. What did I miss? Don't forget that 6 times 1 has to happen. So then you get H is equal to 6. So it takes 6 hours for him to empty the jar. All right, so again, make sure that you're thinking about how you're going to make statements about what your variables represent and what your answer is, not just giving like bald answers. All right, so this last kind, the distance problems, those should not appear on a test. However, they will appear in Math Excel, and I haven't always put them in my slides, but I went ahead and added them because I know that it's something that people have struggled with in the last couple of years, getting their Math Excels done. So I wanted to give you a couple of good examples. All right, so a group of hikers hiked into the Grand Canyon for 3 hours and 30 minutes. Coming back up a trail that was 4 miles shorter, they hiked 2 miles an hour slower and it took them an hour longer. What was their rate going down? All right, so for these problems to work, you have to remember that distance is equal to rate times time. All right, so if we're hiking into the Grand Canyon, what we know is that they have a distance and a rate that we don't know, but we know that their time was 3.5 hours. All right, coming out of the Grand Canyon, what they tell us is that their distance was 4 miles shorter. Their rate was 2 miles an hour slower. And it took them an hour longer. So it took them 4.5 hours. All right, so we've got to find a way to make these like the same. So the easiest way is to just add 4 for this one so that they both say distance is equal to something. So then we can set their distances equal. So if we say into was 3.5 r, that should be equal to 4.5 times r minus 2 plus 4. All right, so multiplied these, thought of this like an entity and multiplied and added 4. All right, so we get 3.5 r equals 4.5 r minus 9 plus 4, just distributing this. Then combining the negative 9 and the 4. Then we will subtract the 4.5 r. And you have to show this too, even though it's like super obvious on a test. If you don't show you're dividing by 1, I have to take a point off, so make sure that you're showing that. And we get that r is 5, and that is their rate. So going into the Grand Canyon, they were going 5 miles an hour. All right, number 2. 2 trains starting at the same station head in opposite directions. So they're starting, they're going opposite directions. They travel 25 kilometers per hour and 40 kilometers per hour. So one of them's doing 25 and the other one's doing 40. If they start at the same time, how long or how soon, how long will it take them to be 195 kilometers apart? All right, so again, remember distance is equal to rate times time. So we want their total distance to be 195. This one's going 25 kilometers per hour. And this one's going 40 kilometers per hour. So H is the hours that they've been going. And then we can just solve this. So combine your like terms, divide by the 65, and you should get 3. So 3 hours is how long it takes them to be 195 kilometers apart. All right, I believe that is all. Yes. All right. Let me know if you have questions.